What is the number of channels in convolutional layers? Imagine looking at a colorful picture and wondering how a computer can understand all those colors and shapes. That's where convolutional layers come into play. They help computers recognize patterns in images by processing data in a special way. But have you ever wondered how many channels are involved in this process? Let's explore that together. In convolutional neural networks, the number of channels in a convolutional layer is like the depth of a layered cake. It tells us how many different feature maps or sets of features the layer is working with. The input to a convolutional layer can have a certain number of channels. For example, a regular color photo has 3 channels: red, green, and blue. These are the basic colors that make up the image. When the image goes through the first layer, these 3 channels are what the network starts with. Now, each filter or kernel in the layer is like a tiny window that looks for specific patterns, such as edges or textures. These filters have a depth that matches the number of input channels. So, if the input has 3 channels, each filter will also have a depth of 3. This means the filter looks at all 3 colors at once to find features. The number of filters used in a layer determines how many different feature maps the layer produces. If a layer uses 12 filters, then it will generate 12 output channels. Each of these channels highlights different features detected by the filters, like lines, curves, or more complex shapes. Think of it as having 12 different lenses, each capturing a unique aspect of the image. As the network gets deeper, the number of channels usually increases. Early layers might have just a few channels, like 16 or 32, focusing on simple features. But later layers can have hundreds of channels, capturing more complex and detailed patterns. This increase helps the network understand intricate details in images or videos. To sum it up, the input channels depend on the data or previous layer, and the output channels are determined by how many filters are used. Each filter produces one feature map, so the number of filters equals the number of output channels. This setup allows convolutional neural networks to learn hierarchical features, from simple edges to complex objects. Understanding how many channels are involved helps us design better AI models for tasks like image recognition, generation, or even analyzing videos. So, next time you see a convolutional layer in action, remember that the number of channels is like the layers of a cake, each one adding more flavor and detail to what the network learns.